Welcome everyone in our today's video. In today's video, we are going to discuss about acid, base, and indicator. We all know that an indicator is a substance which gives a definite color in an acid solution and a different color in a basic solution. Now we have an universal indicator. A universal indicator is a mixture of indicators which shows strength of acids or bases. Now today we are going to look purely on properties of acid, and let's watch this video.
Acids and bases. Citrus fruits such as oranges, lemons and grapes are sour. These fruits taste sour due to the presence of acids. These acids are also found in foods such as vinegar, tamarind and tomatoes. For example, vinegar contains acetic acid, tamarind contains tartaric acid and tomatoes contain oxalic acid. Acid can usually be identified as sour-tasting substances. We also find substances that exhibit properties which are almost chemically opposite to acids. These substances are called bases. Soap, detergent, and baking soda are some of the common bases we find in a household. Let us try to understand these substances in detail. Arrhenius theory. In the year 1884, Swedish scientist Svante August Arrhenius introduced a theory on acids and bases. He defined acids as those substances which release hydrogen ions or H+ ions when dissolved in water, and bases are those substances which give hydroxide ions or OH- when dissolved in water. Bronsted and Lowry theory. In the year 1923, Johannes Nicolaus Bronsted and Thomas Martin Lowry proposed another acid and bases theory. According to their definition, acids are proton donors and bases are proton acceptors. Lewis theory. Gilbert N. Lewis, an American physical chemist, introduced a new concept of acids and bases. He defined acids as an electron pair receptor and bases as an electron pair donor. Identification of acids and bases. When a blue litmus paper is dipped in acid, the color of litmus paper changes from blue to red. When red litmus paper is dipped in a base, the color of the litmus paper changes from red to blue. Phenolphthalein turns colorless in acids, whereas in bases it shows a pink color. Methyl orange in acids gives a red color and in bases it gives a yellow color. In the year 1909, a Danish biochemist, Søren Peter Lauritz Sorensen, introduced a scale to measure acidic or basic strength known as the pH scale. The scale runs from 0 to 14. The pH of acidic solution is less than 7. pH of alkaline solution is greater than 7. pH of neutral solution is 7. If the solution is more acidic, the pH will be very low. If the solution is more basic, the pH will be very high. pH is defined as the negative logarithm of hydrogen ion concentration. pH occupies an important place in our daily life, such as our digestive system has pH. Excess gastric juice produced in our stomach can be neutralized with antacids. pH change leads to tooth decay. Things to remember. Svante August Arrhenius proposed the theory that acids are substances which release H+ ions in aqueous solution and bases are substances which release OH- ions in aqueous solution. Lowry and Bronsted proposed that acids are proton donors and bases are proton acceptors. According to Lewis's concept of acids and bases, acids are electron pair acceptors and bases are electron pair donors. The main acid-base indicators are litmus solution, phenolphthalein and methyl orange. pH is the negative logarithm of hydrogen ion concentration and it has great importance in our day-to-day life. pH scale was introduced by Soren Peter Lauritz Sorensen. The pH value determines the nature of the solution, acidic, basic or neutral.
Now, what happens when acids comes in contact with a metal? We've seen from the video explanation of the term acid. Then they says that acids are substances that when react with the water they produce hydrogen ions, while base are substances when reacted with water they produce hydroxide ions. That is well understood. In the video as well, we also saw that when acids, that they also defined the acids as the proton donors, while the bases are the proton acceptors. Now we want to see what happens when these acids comes in contact with a metal. Now, from the diagram shown on the screen, there is on the first part there is a cork, a test tube which is corked. Then in this test tube there is hydrochloric acid, zinc granules. Then on the other side, in the other diagram, there is a latent splint in a test tube. On top of the test tube, where the test tube contains the contents of hydrochloric acid and the zinc metal. Now this diagram we will use to explain what happens when these acids comes in contact with the metal. In this case, our metal which we are going to form the emphasis on is zinc, while the acid is hydrochloric acid. Now, reactions of acid with the metals. From the diagram I shown before, we saw that there was hydrochloric acid with the zinc granules in a test tube. Now, when the dilute acids are added to the zinc, magnesium, aluminium, iron, those ones are the metals. Now, bubbles of a colorless gas are evolved. In short, they produce bubbles of a colorless gas. The production of the bubbles of a gas is referred to as effervescence. Effervescence is now the gases that are produced from the reaction. The gas produced is hydrogen gas. Now, how do we determine, or rather, how do we know that the gas produced is hydrogen gas? That is why you saw as lightened splint from the previous slide I played on the screen. Now, the role of that lightened splint was to test for the gas produced. Now, the gas produced is hydrogen gas. The gas is tested using the burning splint. A mixture of hydrogen and air burns with a pop sound. This is the test for hydrogen gas. Now, you might be asked in any of the questions that you might be asked to give the test for hydrogen gas, then you will have to say that hydrogen gas burns with a pop sound in air. It burns with a pop sound, and that is the test. Whenever you are asked to show the test of hydrogen gas, it burns with a pop sound in air. Now, when dilute sulfuric acid is added to the zinc granules, hydrogen gas is produced as well as the zinc sulfate is produced. The reaction can be represented by word equation. The word equation is that is the word equation. You add zinc plus sulfuric acid to form a zinc sulfate. In this case, the zinc sulfate is the salt produced, while the hydrogen gas is the gas produced. Magnesium and aluminium react more vigorously with the acids than zinc. Magnesium, now that is now the equation showing how magnesium reacts with the hydrochloric acid. Magnesium reacts with the hydrochloric acid to form magnesium chloride and hydrogen gas. In this case, the magnesium chloride is the salt produced, while the hydrogen gas is the gas produced. As I told you earlier, that the hydrogen gas can always be tested using the burning spleen. It will always burns with a pop sound. Now there is assignment that you will be doing. You will be required to write the word equation for the reaction between aluminum and hydrochloric acid. From this explanation, we can therefore say that acids, from this explanation, we can therefore say that acid is a compound that reacts with a metal to form a salt and a hydrogen gas. Now, there is a video I want to show you. These videos will tell you, you will actually see how the pop sound is produced.
Hi students, in this video we will be looking at the reaction of an acid with a reactive metal to give us a salt and hydrogen gas. Here are our reactants, hydrochloric acid and magnesium ribbon. In the first step, we will add hydrochloric acid into a clean test tube. Next, add a small piece of magnesium ribbon into the test tube and place a stopper over the mouth of the test tube. We observe that there is effervescence and a gas is given off. In order to test for the identity of the gas produced, we will light up a wooden splint over the Bunsen burner. What do you think will happen next? Finally, to obtain a pure and dry sample of the salt produced, we will transfer the salt solution into the evaporating dish. Remember to remove any remaining piece of magnesium ribbon before heating the mixture strongly. Over time, the water boils off, leaving behind the pure magnesium chloride salt.
And now from the video, I hope you saw and you heard the pop sound that was produced when the magnesium reacted. Now, in summary, we can say that an acid is a compound that reacts with the metal to form a salt and a hydrogen gas. Now, a metal, if you add with an acid, metal salt and hydrogen gas is produced. Now at this level we will only see we are interested to see the metal salt that has formed plus the hydrogen. In summary, I'm trying to say that we are interested majorly to see what happens when an acid reacts with the metal. Later we will come to learn on the preparation of salt, and we will see how we can prepare salt in the laboratory using all the methods for preparation of salt. But at this level, let us just understand that when we react a metal with an acid, metal salt is formed and hydrogen gas. Now, very reactive metals like potassium, sodium, and calcium react violently with acid. The reaction of calcium with this dilute sulfuric acid slows down and eventually stops due to the formation of insoluble calcium sulfate. The insoluble salt coats with the metal to prevent further reaction. Now, what we are trying to say is that though these reactions do happen, but they eventually slows down and then they stop. They happen, and potassium reacts with these acids, but the reaction is very violent. It slows down, then it eventually stops. The reason being due to the formation of the salts that are formed when these reactive metals like potassium, the salts that are being formed has an insoluble coat. These insoluble coats prevent the metal from further reaction, and that's why if you react sodium and calcium, the reaction will not go into completion. Why? Because there is an formation of insoluble salt. This insoluble salt coats the metal, preventing further reaction. Take it clear that it reacts. Equation will be set, and you will be much confused. These metals react. The only difference is that they react, but at a point they does not go into completion due to the formation of those insoluble salts. That only happens to the highly very reactive metals. Now the reactions between acids with the metals varies. They are different with how these acids as well reacts with the carbonates and hydrogen carbonates. In carbonates and hydrogen carbonates, the gas which is produced in these reactions, all there is a production of a gas. But now in the reactions of carbonates and hydrogen carbonates, the gas that is produced is not hydrogen gas, as we had discussed, but in carbonates and hydrogen carbonate, the gas which is produced is carbon dioxide. And that is why if in our next class that will be a double class, we will be performing an experiment in our laboratory to see how these carbonates react with the acid. We will be using calcium hydroxide solution. The role of calcium hydroxide solution will be to test the production of carbon dioxide. We will be performing an experiment of sodium carbonate. We will be reacting it with an hydrochloric acid, and to see how those reactions will be taking place. Now, what do we expect when we react an acid with a carbonate? When acid or hydrogen carbonates are added to dilute acids, effervescence occurs. As I had said, this effervescence is due to formation of the production of the carbon dioxide, and then the solid which will be reacted, that is in our case we will be using sodium carbonate. A sodium carbonate will be used up. Now the gas that will be produced is a colorless gas. The colorless gas is which will be produced, that will be carbon dioxide. Now when this carbon dioxide is bubbled through a calcium hydroxide solution, calcium hydroxide solution is what we call the lime water. If carbon dioxide is bubbled through a lime water, then a white precipitate will be formed, and that is what we will be testing in the lab. Now the test, and that will be the test for the carbon dioxide. We say the test for the carbon dioxide is that the white precipitate is formed when carbon dioxide is bubbled through the lime water. The white precipitate is the calcium carbonate. Now the calcium carbonate is formed when carbon dioxide reacts with the lime water. The lime water is the calcium hydroxide. Acids react with carbonates and hydrogen carbonates to produce a salt, water, and carbon dioxide. Three products are formed for this case of the reaction annex. The three products which are formed are salt, water, and the carbon dioxide. Unlike in the reaction of metal with acid, where we formed only two products, that was the hydrogen gas and the metal salt. And the equation for the word equation, that one will also be the part of your assignment. You will be working on them. I want you to do a word equation for the reaction between sodium carbonate and hydrochloric acid, how they react, calcium carbonate as well with the nitric acid, copper carbonate with sulfur acid. Lead reacts slowly with both hydrochloric acid and sulfuric acid, but each reaction eventually stops due to the formation of insoluble coating of lead chloride and lead sulfate. Now, if we react lead with hydrochloric acid and lead with sulfuric acid, the reaction eventually stops due to formation of insoluble coating of lead chloride and lead sulfate respectively. Now, this formation of this insoluble coating prevents further reaction, as we had said in sulfur potassium as well. So lead as well has these characteristics. Though lead is not very reactive, but it reacts slowly with this acid to form an insoluble coating. This coating prevents further reaction, and that is why the reaction stops. Copper does not react with either dilute acid or sulfuric acid. The name of the salt can be easily be derived from the name of the acid used. For example, let's check this table. Now, in the case of magnesium, then the name of the salt formed depends on the type of the acid used. For example, if an hydrochloric acid is used, then the type of salt formed is a chloride salt, and that is why if we add hydrochloric acid to magnesium, we form magnesium chloride. The same thing happens to sulfuric acid. The type of salt formed when a sulfuric 6 acid reacts with a metal is a sulfate salt. For example, if we react a sulfuric acid with magnesium, we form a magnesium sulfate salt. Nitric acid forms a nitrate salt. Carbonic acid forms carbonate salt. Phosphoric acid forms phosphate salt. And that is why if we react a carbonic acid with magnesium, we form magnesium carbonate. Carbonic forms a carbonate salt. Phosphate salts are the product of phosphoric acid. Now that means that the type of the salt form depends on the type of the acids used. Now let us see how acids now react with the bases. Bases are the acids are the substances that produces hydrogen ions, while bases are the ones producing hydroxide ions when diluted in water, or rather when reacted in water. Acids are the proton donors, while bases are the proton acceptors. Now these two can react, and let's see from the video how they
Reaction between an acid and a base to show the process of neutralization. Materials required: dilute hydrochloric acid, dilute sodium hydroxide solution, phenolphthalein, indicator, a measuring cylinder, dropper, test tubes. Take about 5 ml of dilute hydrochloric acid in a test tube. Add 1 to 2 drops of phenolphthalein indicator to the solution and note down if any change in color. What do we observe? We observe that color of the hydrochloric acid solution does not change on addition of phenolphthalein indicator. Phenolphthalein is a weak acid that, despite its pink ion, is colorless in solution. When hydrogen ions H+ as in an acid are introduced to the pink solution, the equilibrium shifts and the solution becomes colorless. Now take about 10 ml of dilute sodium hydroxide solution in another test tube. Take out sodium hydroxide solution with the help of a dropper and start adding the solution drop-wise into the test tube containing hydrochloric acid till a change in color is observed. What do we observe? On adding nearly 5 ml sodium hydroxide solution to the mixture of hydrochloric acid and phenolphthalein solution, the color of the mixture changes to pink. If hydrogen ions H+ as found in an acid were added to the pink solution, the equilibrium would switch and the solution would be colorless. Adding hydroxide ions OH- as found in bases will change the phenolphthalein into its ion and turn the solution pink. With the help of another dropper, take out hydrochloric acid and start adding it drop-wise into the colored solution obtained above. What do we observe? On addition of hydrochloric acid solution to the pink solution, the color starts fading gradually and finally the solution becomes colorless. When hydrogen ions H+ as in an acid are introduced to the pink solution, the equilibrium shifts and the solution becomes colorless. Precautions: be careful while handling the acid.
okay. Now
Reaction
from the From the video, we've seen how neutralization occurs. Now, neutralization is a neutralization reaction is a type of reaction where the acids react with the bases to produce water and salt. Now, explanation: phenolphthalein indicator is used to determine the end of the reaction. The end of the reaction, that is what is called the end point. If the reactions comes to an end, that is the end point. Now, phenolphthalein is used to determine the end point. Now, how do we know that the end point has been achieved? The color of phenolphthalein is always pink in basic solution. That one we all know. Now, at the end of the reaction, that is the end point, the color of the indicator, that is phenolphthalein, in the solution turns from pink to colorless. Now, immediately it turns from pink to colorless. That is when we say the end point has been achieved, and that is why we use phenolphthalein indicator to determine the end point of the reaction. Now, when acids react with bases, they form a salt and water as the only product. Now, any reactions that produces salt and water as the only product, that those types of reactions are referred to us as a neutralization reaction. Now, salt and water are neutral products. Salt and water, these are neutral products. From the first, the introductory video that we had watched earlier, we saw that the variation in the pH values of this one, and we saw that, and we said, as it was explained in the video, that acids has a pH value that is below 7. Then the pH values above the 7 was the bases, and there were different colors. Now, the colorless one, water and salt, has a pH value of 7, and anything that has a pH value of 7, we say it is a neutral. That is why we say water and salt are neutral products, since they have a pH value of 7. Sodium hydroxide reacts with the dilute hydrochloric acid to form sodium chloride and water only. The sodium chloride in this case is the salt. Then we can write the word equation as shown: sodium hydroxide plus hydrochloric acid to form sodium chloride and water. Not only those ones, not only sodium hydroxide is a base that can react with the hydrochloric acid to form a neutral product, or the neutralization reaction, but there are other metal oxides that can react with the acids to form a salt and a water, and these ones as well are neutralization reaction. An example is calcium oxide. If we react a calcium oxide plus an hydrochloric acid, we form calcium chloride. Calcium chloride is generally a salt, the common salt, plus water. Zinc oxide as well react with hydrochloric acid to form zinc chloride plus water. We can see the same reaction when magnesium oxide is reacted with the nitric acid to form magnesium nitrate plus water. As we discussed earlier, that nitric acid produces nitrate salt. So the same type of reaction we expect to see from lead 2 oxide and copper as well, copper oxide. From the previous slide, we said that copper does not react with acids, and that is true. Copper is generally unreactive with acid, but copper oxide reacts with sulfuric acid, to form copper sulfate and water. And therefore, we can conclude that a base is a substance which when reacted with acid, it forms salt and water as the only product. And we also know that bases are hydrolyzed in water to form hydroxide ions. Hydroxide ions is OH with a negative charge. Now metal oxide, metal hydroxides, and ammonia solutions are the bases. In our introductory video, we saw some of the bases, and we said that bases have a bitter taste and the acid has a sour taste. This brings me to come to comparison between an acid and a base. The comparison, the general one and most obvious, we will talk about the taste. We will say that acids has a sour taste while bases have a bitter taste. Acids has a pH below 7 as we had seen earlier, and the bases has a pH value that are above 7, right? And from the indicators, we have litmus, phenolphthalein, and methyl orange. We said that litmus paper turns red in acid and it turns blue in a base, while phenolphthalein is colorless in an acid and pink in bases, while methyl orange is pink in acid and yellow in bases. Allow me to stop there, and please watch the video and subscribe. Thank you.